All right, we're going to finish up 2.5. I believe we're on question 13 is where I left off. A school administrator expects that less than 15% of students will fail the final math exam given to all juniors. If a sample of 40 test students are given the test and only 2 fail, is that evidence that the administrator is correct? I guess that should say incorrect. So, is this one-tailed or two-tailed? One-tailed because we're shading to the left. So the null is going to be pi is 0.15, and the alternative would be pi is less than 0.15. Are we going to use simulation or the theoretical model? Simulation because we have 2 failures. We have enough successes. You need more than 10 successes, and you need more than 10 failures, and we don't have that many. So we have to use the simulation. What is our sample statistic? 2 out of 40, so 0.05. And we are going to use p-value because we're using a simulation. So I'm assuming 0.15. And my sample size is 40. So we run that simulation, and we're going to test 2 out of 40, which is 0.05. And we're going to shade to the left. And I get a p-value of 0.076, which means, oh, I'm still two-sided. Thank you. So shading to the left, I get a p-value of 0.05. So I'm not going to reject, right? So this is kind of one of those areas where we're like, ugh. Is there enough evidence to suggest that it's wrong? Maybe. There is some evidence that he's wrong, but it's not super convincing. Now, you might have got a different answer. How come? This is a simulation, right? Your simulation might have a histogram that is different enough that maybe you got 4.9%. So we're kind of right on the edge. Okay. A company claims that 75% of their employees are satisfied with their jobs. A random sample of 75 employees shows that 63 are satisfied. Is this evidence to support the company's claim? One or two-sided? One-sided, because we're shading to the right. The null is going to be 0.75, and the alternative is going to be pi is greater than 0.75. Are we going to use simulation or the theoretical model? Just barely the theoretical. I have 12 failures. So I don't need to draw any samples. I can just run this. So my standard deviation is going to be the square root of 0.75 times 0.25 divided by 75. What did that give you? Is that 0.05? Is that what you guys said? That's the standard deviation. So my z-score is my p-hat, which is 63 out of 0.7, 63 out of 75 is 84% minus 75% divided by 0.05, and I get a z-score of 1.8. Now we decided that this is a one-tailed test. Is that far enough away to give us evidence against the null? Yes, just barely. What's the cutoff? 1.65. Why is the cutoff 1.65? Because that is 5%. So when a one-tailed test has a z-score of 1.65, that means that the p-value is 5%. Okay. I'm only a little sick. I'm getting better. All right. A news article states that 85% of adults believe the Earth is round. Well, that's good to know. A random sample of 400 adults shows that 310 believe in a round Earth. Is that evidence to support the claim? One-tailed or two-tailed? 2. The null is going to be 0.85, and the alternative is going to be greater or not equal to 0.85. Are we going to use simulation or theory? Theory. What is our sample statistic? It's 310 over 400, which is 0.775. So the standard deviation for this normal curve is going to be the square root of 0.85 times 0.15 over 400. What does that give me? 0.018. Now we need a z-score. 0.775 minus 0.85 over 0.018 is negative 4.2. Okay. What are we going to compare that to? What is the z-score cutoff for a two-tailed test? 1.96, or in this case, negative 1.96, right? So are we going to accept the null or reject the null? Reject it for sure. Do we think the true percentage is 85%? No, we don't. We do not. Okay. A company claims that 70% of their customers are repeat customers. A random sample of 35 customers shows that 26 are repeat customers. Does this support the company's claim? One-tailed or two-tailed? 2. So the null is going to be pi is equal to 0.7, and the alternative is going to be pi is not equal to 0.7. Are we going to use simulation or theoretical model? Simulation. How come? We only have 9 failures. We have 26 successes, but only 9 failures. And again, these rules are not hard and fast. You can technically use simulation all the time, but it's just more work. The theory model is so much easier to do, but the theory models are less accurate when your sample size is small. And it's not necessarily sample size, but if either your failures or your successes are really small, then the theoretical model is not very accurate. All right. So what is our sample statistic? What is 26 over 35? 0.743. So our probability of success is 0.7. And we have a sample size of 35. And we run the simulation. And we're going to test that against 26. And we're going to do so that's 0.7429, and we decided this was a two-tailed test, right? So we have to test both sides, and I get a p-value of 71%. We're going to accept the null. We have no evidence to suggest that the null hypothesis is inaccurate. Hey, that was a good question. State your conclusions from. Is that what they all say? Oh, well, I'll fix that. A pharmaceutical company claims that 10% of patients experience side effects from their new drug. A hospital administers the drug to 200 patients and records that 14 experience side effects. Does that support the company's claim? So this is going to be a two-tailed test, and we're going to use the theory model, and our sample statistic is 7%. So our standard deviation is going to be the square root of 0.1 times 0.9 over 200. What is that? Nope. Nobody get that far? Okay. Well, oh, I have a calculator. I don't need you guys. So square root of 0.1 times 0.9 divided by 200. So 0.02121. Okay. And then we have 0.07 minus 0.1 divided by 0.02121. What is the z-score? Should be negative, right? Negative 1.4. What does that lead us to do? Accept the null. Okay. What if we run the same test with 400 patients and 28 report side effects? What is that going to change? Does that change this calculation? Yes. So we get a 400 in there instead of a 200. So let's change this to a 400. And that makes my standard deviation smaller. So a smaller standard deviation is going to have what effect on a z-score? It's going to make the z-score bigger. So let's do the z-score calculation. Did my sample statistic change? I went from 14 out of 200, which is 7%, to 28 out of 400, which is also 7%. So 0.07 minus 0.1, and now we're going to divide it by 0.015, and I get a z-score of negative 2. And now we're going to reject the null. So why is that the case? Why did adding more people and not changing the sample statistic change the value? Because a larger sample size created a smaller standard deviation, which created a larger p-value, a larger z-score, which creates a smaller p-value. Right. Blake believes that school is overrated. Hey, that hurts my feelings. He is convinced that most of his peers feel the same way. When he talks to 18 kids in his grade, 11 of them agree. Is this one-tailed or two-tailed? One. Why? We're going to do greater than 50%. So the null is pi is equal to 0.5, and the alternative is pi is greater than 0.5. Simulation or theoretical? We got to use simulation. What is our sample statistic? 11 out of 18. And let's do this. Run that. And what was it, 11? So 0.611. And I need to undo two-sided. So what do we tell Blake? He's wrong. You're wrong. Are we testing if school is overrated? No. We're testing if more than half of the students at the school think it's overrated. Right? Being overrated or not is a judgment call, and in statistics we don't do judgment calls. Okay. So if Blake talked to everyone in his grade and he found that 71 out of 140 students, I guess I should put thought school is overrated, is that evidence to support his claim? Yes. The answer is yes. I haven't done a single calculation. Well, I did one. I did one of them in my head. 71 out of 140 is greater than half. So why is the answer to this question yes, without doing anything else? It's over half and Should we run a simulation or should we do a theoretical model? We don't need to. Why? No. I talk to everybody. Right? So the original question said, Blake thinks that more than half of his peers think school is overrated. So we have two options. We can either talk to a subset of the population and run a test, or the other option would be talk to everybody. So all of the hypothesis tests, we're saying maybe, probably, probably not. But this is the one case on this worksheet where the answer is yes, Blake is correct. And he is correct because we talked to everybody and we and we got a value that was above 50%, and we don't need to run a test. In fact, if we did run a test, it's going to be misleading. You guys probably all ran a test, right? Did you all accept the null? So if you ran a test and you accepted the null, that's totally inaccurate. Because if you speak to the population, then you know the parameter. And the null hypothesis said pi is 0.5, and the alternative said pi is greater than 0.5. We now know that this is true. It's not probably true or most likely true or significantly true or anything like that. It is true, 100% true, because we talked to everybody and we got a value that was greater than 0.5. Okay, that's it.